Hi guys, welcome to Learning Electronics Repair, and we have something a little bit different today. So this is on my bench. We can see GTO 1100 watt by JBL GTO 6000 power amplifier. So this is obviously for a car or a van. So this thing, with the connectors, about 58 centimeters that way, and what do we have? About 30 that way. That's big. This supposedly is dead. Okay, so let's have a look. And first things first, there's two fuses. Okay, so we should really start with the fuses. Okay, 30 amp, 30 amp. They look okay, they look intact. Yeah, I don't look stressed at all. Let's see. Yeah, that one's good. That one's good. So I doubt there's any short circuit in this unless somebody's replaced the fuse afterwards. Yeah. So if we go to ground, 12 volts, what do we see? Well, it's charging some capacitors up in there, you can see that, okay? The other connection here, this one says REM. Okay, the other one is plus 12 volts. REM is not like rapid eye movement or the name of some indie type band, yeah. It is remote. So if you're not familiar with these things, basically, ground and 12 volts, and then you have to connect 12 volts to REM as well for it to power up. Okay, it's kind of like a soft start, I guess, is probably the best way you would put that. So let's wire this up onto the bench power supply. I'll get the 10 amp one. Let's see how much power it actually draws, but I will set a current limit first. I want to be sure nothing bad happens. Yeah, I've set my power supply to about 12.5 volts, good enough. I've set the current limit to 2 amps at the moment. Let's see what it does. Wow. Interestingly, I thought it was set to 12 volts, it isn't. Must have knocked the button. Something's flicking on here. It's going to the current limit, I can see that. So yeah, it's going to the current limit. Let's turn the current up. In fact, I've turned it up to full now. And it's still doing the same thing. So it's no longer going to current limit. This just flashes on and off occasionally there, yeah? Okay, you can see it. I'll just move my multimeter out of the way there for you guys. So not exactly dead. It's kind of like powering up and shutting back down again. Okay, you can see that. Now, there's probably one particular good reason why that might be. So what we actually have in here, we have the 12 volts coming in. You can see these two big inductors, the transformers in actual fact, most likely. So here we'll have DC to DC converters. Now, these will take the incoming 12 volts and generate a much higher plus and minus supply for the amplifier, okay? They may be generating a single plus and minus voltage, say plus and minus 50 or whatever it happens to be, 90 or something. They may be generating two sets of voltages, something like a plus and minus 45, plus and minus 90. That would make this a class G amplifier. It doesn't look like a class D, by the way, because just the layout of it, I'm pretty sure these are class AB amplifiers. We will get to that. I mean, there are some other inductors and things down here. Could be wrong, we will see. All this is just looking around at the moment, yes guys. It could well be that these two power supplies are in parallel with each other to give more current on a single plus and minus rail. Depending on how many windings on here, could be both in parallel with dual plus and minus. Yeah, so we have a number of options, but the important thing is this is a power supply and this is generating a higher voltage for the amplifier, or higher voltages for the amplifier, okay? And the way this is behaving looks very much to me like the power supply probably works. It comes up and then shuts down due to overcurrent. And the reason for overcurrent would be some sort of short in the amplifier. Yeah, probably output transistors or MOSFETs. And we don't see that on the 12 volts because the power supply is in between. So the way that behaves to me suggests short circuits in the actual amplifier part. So let's figure out how to get into this and we'll have a look. Okay, I'm just trying to get into this and it smells like something's burnt in there actually to me. Let me see if we can just get this. I can show you guys because this has been a pain in the butt. So this top panel here won't slide back, it will slide forwards. Now there's a PCB attached to this, okay, you can probably see it in there, and when I try to slide it forwards the PCB hits a relay behind it and won't go any further than that. So I need to get that PCB off, and it looks like I have to somehow remove this plastic bit, but it seems to be bonded to the other bit. I'm guessing this does come off. Try a spudger or something. If I can get this off, I think I can unscrew the PCB that's attached. But I'm not sure this is meant to come off. Ow! Ow! Or maybe it is meant to come off, but you require the correct tool to do it. Probably a bit of warming up would help, but I think it's going to come. Well, sodding typical, it happens, okay. And the screws are under here, so I had to get this off. Yeah. All we can really do is stick it back together, guys. Can't do anything else than that. Unless you have the scrap one. Okay, let's continue. So now I can remove the PCB and I can actually get this thing out. Like so. Okay, if we have some shorts in the amplifier, it's probably going to be on the power devices which are under here. You can see down there some big MOSFETs or transistors. Okay, obviously there are also power devices under here in the power supply. These will be MOSFETs. And it is possible the power supply does have a problem. It may not be a short in the amplifier. I just think it's the more likely scenario. But there could be something wrong in the power supply itself which causes it to trip out. Either thinks there's an overcurrent or thinks there's an over voltage or some sort of condition. Maybe there is an over voltage generated on the power supply. So it is possible the problem is in there. And really, we need to separate this problem now to two halves. Is the fault somewhere in here, or is the fault somewhere in here? Okay, so let's go for the low-hanging fruit here. Let's just take these off so we can get to the power devices, and let's see if we find any short circuits. Okay, so these in actual fact you don't need to remove all the screws. If you loosen them, these will slide out. Obviously I've never worked on one of these before, as it's fairly obvious from what happened to the little cover there. Yeah, these things just come with experience, so if you see one of these, you know about the glue and you know about these. Yeah, see, the other one hit a capacitor and this one's going to do the same thing, so I just bend the capacitor, and now I find it hits the connector here, the inputs, so you know, things are never as easy as you'd think they should be. Move that out of the way. Now it'll come out. I'll just unplug this so it's not waggling around. Okay, let's see. Yep, without breaking anything else. Right. I still can't easily get down to these devices. Now let's slide that thing out of the way. Know that one here as well. Yeah, it's just held in place, just a bit sticky, really, probably sticking against the little heat conductive, whatever we want to call it down there, yeah, to stop the transistor shorting against the chassis. So that's what we have under there. Let's have a closer look. Big transistors, tip 35, tip 36, D718, like probably 2SD, 2SB, 2SD, 2SB. Okay, so we have basically 3 pairs, and the same down here. Okay, it's likely that each pair is an amplifier, so in no particular order, but right front, right left, rear front, rear left, and then the other 2 probably work in bridge mode for the subwoofer. Okay, that's how we'd expect that to be. Right, do we have any short circuits in that lot? The other devices look like they might be 3-pin actually, especially that one. Not sure exactly what they are at the moment. They could just be for monitoring temperature. I'm mostly interested in these big transistors. Let's see, so we can pretty much always say that this will be the gate or the base. That reads like a diode junction. So base collector. Now I'm expecting this to read low. Actually it didn't. I thought there might be quite a low base emitter resistor. And that doesn't look particularly good. Okay, bear in mind we'll have NPN and PNP probably here, so this looks like an NPN because red to the base. Okay, but I also get a reading that way, which is strange. And then collector, emitter or drain source with a positive to the collector. For an NPN you'd expect that's probably going to be positive coming in. Reads lower than I would expect. Other way also reads lower. Let's look at these. Same sort of thing. Okay, this one, I see that pretty much everywhere. Okay. Yeah, on that one as well. Oh, that's increased. Okay, so that's a capacitor charging up. Go back to this one. Well, what do you know? I see a capacitor charging up. But I can't imagine really why there's a capacitor between the collector and the emitter of what I'm assuming is an audio amplifier output transistor. Let's look on the other side. Somebody has probably been here before me, because that's a different colour. What do we have? That's the thing with the capacitor charging. Again there. But the reading doesn't go open. It doesn't like go really high, okay? There's something wrong with this for sure. That one is different. So that only has 2 pins on. That reads short. That one. Yeah. Okay, well we definitely have one short. I'm a bit puzzled. Oh! Look at this. There's only 2 pins on that thing because the other leg there has been cut off. And somebody has soldered from the tab to here on that black wire. This is a bodge, yeah. And you think I did bad breaking the little cover. Yeah, look at this. Okay, so we have to get the PCB off. Of course, this again is much harder than it needs to be because you can't get this out. It hits there. The other side's even worse. Okay, so you can't get them out of the way. All that seems to be holding the PCB in is the fact that the transistor is effectively stuck to that insulator. Yeah, that thing. Generally, I find the best way to loosen these is to get under the leg and just kind of like see if you can prise it up a little bit. Because if you try to get under where the tab is, you might well damage the insulation, yeah. Whereas if you go the way I did it, you probably won't. Now, I need to get all these loose, so you can see all that what there are now loose. The same on this side, before I can try and slide the whole PCB out, and it's probably going to be held down because these are stuck as well, and it's probably going to be a pain in the butt. Okay, so this end is now loose. I might be able to get these off if I take these bolts completely out and then slide them that way. And while I'm just doing this, I don't see there's any likelihood I'm going to fix this thing today because I'm going to need parts, okay, and check the availability of the parts. So if you're disappointed by the fact I don't always fix things on the first video, then look away now, yeah. I think we're learning quite a bit anyway in the experience. That's my view. This is why I do it. This is the reality of this sort of work. Sure, if you're a specialist workshop on, for example, you know, like these type of audio amplifiers, you may well keep a wider range of parts in for that particular type of thing, yeah, because you're seeing the same type of devices on a regular basis. In my case, because I'm a kind of like jack of all trades, and some may say master of none, yeah, I don't have that luxury really. So yeah, normally with something like this I will order more parts than I need, or a higher quantity of each part than I need, in case A, I blow it back up again the first time or second time, and B, because I think, well, if I've seen one faulty, I'll probably see some more in the future, yeah. So I do, but I'm pretty sure I won't have these transistors. Okay, so this technique is working. You see, you can't go all the way. You have to take them out, yeah, because of these capacitors. This is why I say the thing is, yeah, it's like you can work on it, but they certainly didn't make it easy. Okay, you see. I better write top on these so I remember which ones were which. Maybe this will come that way. No. They really didn't want this thing to come apart, did they? I'll see if I can loosen the devices and get this out with that still attached, yeah. So, yeah, you see how that just, you probably can't see it, but it kind of like went click as it came away from the pad underneath it. So that one just bent the leg, yeah, that then it went, okay. And that's all that's holding this down. Yeah, nothing else. I think I will need to find a way to get this out. Oh. Well, if you get it in just the right position, I think I can get it out this way. Yeah, look. That's how fiddly it was, yeah? So fiddly, I'm going to make a note. It's the bottom one and that's towards the rear. Okay, so same problem. We have these devices that have just stuck themselves to the pad. There you see. Now you probably did see that one go. Yeah. Yeah. I mean, this may not be the best way, but it works, okay? Down there, guys, yeah? Right. Still something towards the middle holding this down. Not these. Ah, screw. 1, 2. Okay, now we have it, and we can see this botch much more clearly. So I really need to sort that out. This is the one that's read short, and you can see it's like a different style device. What is it in actual fact? B688. What's on the other side? Yeah, so it's the same part number, but kind of like a different package. You see. And again, with this one that's got the thing soldered to it, that lead, I don't know whether that is like really bad workmanship or really good thinking out of the box. Yeah, the technician who did this is either really good or really bad, and that's a good discussion down there. Yeah, that's a good discussion. So D718, yeah, all D718s. Okay, I think I'm going to take them all off and check them out. I mean, because these are separate amplifiers, we don't have a problem with matching the output devices. Yeah, they're not like in parallel. Let's see. And I often change my mind. You know what I'm going to do? I'm going to unsolder those two and then measure again. But I may well end up taking all the rest off as well. I think we can draw some other conclusions here as well. So these two amplifiers and these two with these B and D transistors, yeah, And the one in the middle, by the way, is, yeah, it looks like a transistor that's behind that rubber thing. Can you see it there now? K228 C. Oh, C3200, not K228. Yeah, C3200. These are also transistors. Okay, one on each pair. So I'm guessing they are drivers of some sort, possibly. I mean, there's other ones down here as well, which also look rather more like driver transistors than they do. Yeah. But the conclusions, I digress. So, because these four are basically the same, I think we can probably say that these are your four channels. So, front, right and left, rear, right and left. And then those ones which have the TIP 35 and 36 transistors are probably the ones that are in bridge mode for the sub, because it's different. This also has these larger drivers, okay, than those do. So that also suggests this is the sub amp. It also suggests possibly that if I can't easily get these B's and D's, I may possibly be able to replace them with these, which are, I'm just guessing, are higher power transistors, but then they probably have more base drive, so I'm not sure that is the case. It's just kind of mulling it over. Okay, so let's unsolder these two now. Interesting what you guys think, by the way, if we can't get these transistors. Another conclusion we could draw, maybe, is that because these are blown up again, looks like they've obviously been replaced before and they're faulty, certainly this one is that because this is just not rated the same as other transistors? Is it a fake or something? Is there some reason why that's blown related to the transistor, rather than some reason because there was something else wrong in this amplifier channel? Yeah, because we have four the same, okay, one's got faulty output devices, there's a good reason to use the curve tracer on this and go through each of these four to see if we can see any obvious differences. Yeah, so that's another possible. This could be a good one for the curve tracer. Because we can look at the two, you know, channels at the same time and just looking for differences. Yeah. I have my desolderer warming up, but I'm just thinking maybe I can get this out actually. Yeah. Bit warm, but it's coming. It's loose. Okay. Maybe I don't need the desoldering gun at all. Well, actually, let's see if it's easier than that was, yeah? Let's do a comparison. So, I did that one with braid. Let's try this with a desoldering gun and see if it's any better or worse. Well, this only has the two pins because of the ones just the wire. I would say actually probably no real difference in this instance because the pins are too big legs to get the vacuum tool over. Yeah. Okay. What do you think, guys? I don't think there's any much difference at all there. So what do we have? That one is short. It's also short to the base, which makes me think there may be other problems in that amplifier. That reads open in that direction. Maybe this is an NPN. No, that one actually just reads open. Okay. Yeah, so this one's open, the other one is short. Let's look at the other channels, see what we have now. So we know these three are the same amplifiers. That one is somewhat different. What we have, so that's got a low reading. That reads with a low reading. Yeah, that's climbing up now at least. This will be the PMP or vice versa, okay. Probably the PMP. I'm not generally happy with what I see around the other amplifiers. Now, because of these have failed, there's no reason particularly why the other ones should have failed as well, the separate amplifiers, but I'm not totally convinced about these in circuits, so I'm going to take them all out, I think, and let's have a look. Seeing as we're trying different techniques, just the soldering iron, try to warm all the pins at the same time. It moved a little bit. Yeah. Just wait for the solder to solidify again. Well, the other one actually I did this way, it came out really easy. This one doesn't. Okay. Yeah, it did then. Okay, so that's another way. And afterwards you can easily then just remove the solder. Some people have commented about me using quite a lot of solder braid. Guys, solder braid is a consumable. Okay. I buy a pack of 10 of these and they last me ages. I've just bought myself a new pack of 10 because I had 2 left, but they probably lasted me a year. And I don't always use braid. Sometimes I do use the vacuum tools, you know. I use various methods. Possibly depending on what mood I'm in. Today I'm in the chatty mood, by the way. You might have noticed that. Okay. I have no particular reason to suspect these are faulty. It's just that I see some strange readings around them. So let's just eliminate that. Okay, this time it isn't working. Bit of leaded solder. Try again. Now it's working a bit better. Yeah. You want to be careful with this if there's like wires or something or the plated through holes. Yeah. Make sure the thing is actually melted. Don't kind of like force these things out, you know. Just gentle, yeah. I've also made a note on the PCB which one's a B and which one's a D. Best time to do that is before you take them out, okay. There we go. Remember to add the cost of the consumables used, like braid, to the bill each time you use, yeah. I mean, these things are like €2 something each. I got 20, say 23 for a whole pack or something. So, you know, just add like €5 when you run out of one. Whoever's unlucky, like an unlucky dip, yeah. And then they paid for, okay, when you need some more. Of course, you'll spend the money on beer, then you won't have the money, but that's another topic, yeah. Okay, let's see what we have. PMP silicon, that's one of the B688. Gain 111. Here's another one of the B. Yeah. Much different gain, but these are from different amplifiers, so we don't have that issue of matching the gains. Yeah, there's only one pair per channel. Okay, how about the NPN transistors? So these are the D718s. Yeah, a good one. I think, as I mentioned, this is not unsurprising because there's no real reason why these should fail, because the other channel failed. Yeah, gain lower. Or was it higher? I should have been paying attention there. Yeah. Yeah, so those are all okay, which suggests that the amplifiers they came out of are also okay. This is where the one was soldered in, the botched one. Okay, so if we get the curve tracer and we just go through each of the channels because they're identical and have a look around, yeah, if they look the same as each other, I think we can say the problem is only the output transistors, but because one was shorted to the base, makes me think there might be some other issue. Okay, let's find out. So previously I would have used my multimeter in diode mode and checked all the diodes I could find, all the transistor junctions I could find on two of the amplifier channels, and see if I could see a difference. But the curve tracer just seems a lot better for this. I've clipped the ground lead on here, so I actually plugged this in. I wasn't exactly sure where ground was, but I know these will be ground where you connect the audio input. These markings D and B, that's so I know which transistor goes where. I put an X on this, not because the capacitor is bad, although who knows, but not for that reason. I put an X on. This is the channel that had the short circuit and the open circuit transistors. Okay, we can see the layout is slightly different actually in this respect at least. So capacitor there, and we can see they both look the same on the curve tracer. Okay, the slightly different layout could cause some confusion, but that end also looks the same on both. Ground, this is the one with the X. So it doesn't really matter where you measure, you're just looking for differences. Looks the same. Let's go to this transistor thing. So we're on here, and you can see that they both look the same. Okay, middle one, okay, look the same. This end look the same. Let's stick with transistors then, and we can see 1, 2, 3, 4, then 1, 2, 3, 4. So no real difference in the layout. Okay, you see the pattern and the same. So I'm going to keep on doing this. Won't have you guys sitting and watching the whole process, and I'll tell you if I spot any differences. Okay, so I've been through all the transistors, I've done all the legs, compared. I also had a look around these electrolytic capacitors, and I had a look around these resistors, and I don't see any difference between the two channels. So there's a very good likelihood that it is just the output devices, and there's a very low likelihood they would fail due to something in here. Yeah, by that I mean fail once I replace them. So let's see if we can get these transistors. And this thing is becoming like the Dremel again. It's becoming invaluable. I had used them back in the 80s. I'd messed around with one a little bit since then, but never really used one. And now I'm thinking, how did I manage without that? Yeah. So, invaluable. For those of you who think this is expensive, and personally I think for the €80 or thereabouts it costs, this is not expensive considering what I'm doing with it and the potential to make more money using it. But for those of you who think it is expensive, there's another version of this from the same manufacturer for about 20 to 30 euros, but it doesn't have a built-in screen. It's not a standalone unit like this. It's meant to attach to an oscilloscope. Now, that might sound like it's just as good, and it may be, actually. We'll find out, because we're going to get one and try it next month, okay? But bear in mind, the oscilloscope you attach it to has to have XY mode, and that eliminates pretty much all of the cheap handheld scopes I've seen. Even some of the more expensive ones don't have XY mode. Even some of the bench oscilloscopes don't have XY mode. Some do, okay? So I have at least 3, I think, digital scopes with XY mode, and I have 2 analog scopes with XY. So let's get one next month and give it a try. But for the convenience, I just don't think you can beat this thing, okay? Again, I know a lot of you have bought them. Have you had them yet? Have they arrived? What do you think of it yourself? Down there. There are a few sellers then with these. These ones at the picture at least have the K logo on, like I could see on the ones I have. Okay, new original. I think I've actually bought from this seller before. 37 sold. So €6 for the 10 of the B and 6 for the 10 of the D. There's another seller I spotted as well, but they seem to be marked slightly different. But this has very good reviews in Spanish, but I can read the Spanish, okay. They look cheaper, but you've got some postage on, so they're basically the same, might be a little bit cheaper. I'll probably go for these because they look like the ones I have, okay. 10 of each looks like 6th to 20th of August, but if I only need 1 pair, I won't have to wait for these again. I should be able to test these at least to see they can handle the current when they arrive before I fit them. But yeah, I'll order those ones, okay. The €12 will go onto the bill for parts. I don't make anything off the parts in that case, but at least I get a lot for myself. Otherwise, well, we know the power supply was coming up and shutting down. It had a short on the output. Why wouldn't it do that? So I'm confident enough the power supply will be okay. Curve tester tells me there is no difference here, so I'm confident enough that the amplifier is okay. Yeah, I think that's a pretty good job so far done on that one. Okay guys, so let's find out when the parts arrive, and then I'll have all the fun of putting the damn thing back together again. Hope that's not worse than taking it apart. I'll have to repair that little plastic cover. I'll just glue it back on and that'll have to be it, yeah. I mean, the thing's a little bit knocked about. It's not like it's in exactly showroom condition to start off with. Unfortunate, but hey, guys, this happens. This is life. This is repair work, yeah. Hope you enjoyed that. I look forward to hearing from you in the comments below. And I also look forward to seeing you all soon again on Learning Electronics Repair. Ciao for now, guys.